Hi. Yeah, so like it's been said, I'm primarily a PHP developer. Sometimes I have to do some Java as well. Boo. But I also get roped into doing DevOpsy type things because I kind of know like how to set up Nginx, and that's all you need, right? So sometimes I get roped into doing DevOps things as well, and I used to hate it. But the things I'm going to talk about are a number of things that I've been doing with these guys, the Home Office, which have actually really changed my opinion about DevOps and made it something that I kind of enjoy now, rather than some horrible, painful exercise. So the two tools that I'm going to be talking about that we use that's really changed my opinion is, first of all, Kubernetes, and also Docker. So how this talk is going to work, first I'm going to start off giving you a kind of brief overview of Docker. It's not going to be as in-depth as the one that some of you saw kind of yesterday, but it's probably going to mention a couple of things which weren't mentioned in that. And then I'm going to move on to talking about Kubernetes, which is a tool for managing a Docker over multiple hosts. And then finally, because the actual code is only part of the problem when it comes to any technical solution, I'm going to talk about the cultural changes we need to put in place at the Home Office in order to take advantage of these tools properly. Okay, so let's get started with Docker. So what is Docker? So Docker is an open platform for developing and shipping and running applications. It is designed to deliver your applications faster. And that means precisely nothing, right? It's just a nice bit of marketing speak. So what Docker is really is a fancy wrapper around something called cgroups. And cgroups is a feature of the Linux kernel, and what it allows you to do is put some clever controls around your processes, controlling which files they can access, how much memory they can use. A really simple way of thinking of it is Cheroot on steroids. Okay, so as I've just mentioned, Docker uses a feature of the Linux kernel, which means it's never going to run on Windows, it's never going to run on Mac, so you're going to have to run it on a VM if you've got a shiny Mac like me, or if you've got a shiny Windows machine, but if you've got a shiny Linux machine, then you're sorted and you can just run it natively. Okay, so in practical terms, what this means is Docker is a service which gives you walls between your applications. It means you can run maybe Nginx, PHP, MySQL, all on the same host, and not have them interact in any way and have them be isolated. But more than that, you can run multiple versions of these bits of software with competing dependent libraries and still have them all work together and have no like horrible dependency hell. So on top of this, so in order to achieve this, Docker gives you a few things. So the first thing that Docker gives you is an isolated file system, and this is a layered filing system, and I'll come into why that's important later on. And this means that with every single application you run in Docker, you bring its own file system, and this file system is isolated to that specific application. It's like having a mini VM. So if you think about the other things that an application really needs to have in order to run in isolation, the other thing that I always think of is, because sometimes I write Java apps, all the Java apps always want to bind on port 8080 if it's a web app, which is a bit of a pain. What Docker does is it gives you a standard way to remap those ports and say, okay, so this port is running on the container on 8080, but actually on my host I'm going to expose that on a different port. So this means together that you can run multiple different applications in multiple different versions, which maybe depend on specific configuration files, all on the same host without ever worrying about them conflicting, because it's just not going to happen. They're isolated. Okay, so I think that's probably enough about what Docker is. So this is how you run a container in Docker. So this is a really simple command. So it's docker run, and then the name's optional. I just like to have a name because it's a bit easier than using hashes. And then at the bottom, what I'm saying is map port 80 on the container that I'm going to run to port 80 on my VM. And at the bottom is it's a name of a container that I'm going to run. Now, you might notice this looks a bit like a URL. That's because it is. And what it's saying is go to the key.io registry to download this container under the user purple booth, which is me, and run the Flappy Endpoint. Now, the Flappy Endpoint is a container I made earlier. It's primarily made from code that I borrowed from one of my friends, Ben, and he does this fantastic logging talk, and I was like, oh, that's a really good training example, because it's an endpoint which returns lots of different status codes. And I nicked that up, I packaged it up in Docker, and I put it up there. So the thing about this command is if you run this on your machine right now, and you've got an internet connection Docker set up, this will run. This will start the application, it will go away to key, and it will download it. And when we do that, that looks a bit like this. So in the Docker run, we're going to pass in the name, and then we're going to map port 80 to port 80 on the VM, and then I'm going to put in the name, and I copy and paste it because I can't type. Okay, so the first thing that you'll notice is a whole bunch of logs are being output to the screen. Docker logs to stand it out. This is important, and I'll come on to why it's important, what you have to do for your applications in Docker later on. So that's the IP of my virtual machine, which is running Docker. I use something called boot to Docker. Docker machine is a newer version of this. Okay, so you can see that I've got the web page up now. There are two endpoints, one which returns random data, one which returns 200 every time. And you can see that when I'm hitting that endpoint, it's outputting the logs from Apache. So I'm just going to stop this image now. And I'll prove to you that this wasn't some horrible trick and that it is actually running on that host. Yeah, the container stopped and the service has gone away. Magic, right? Okay, so before I talk about like how you can make your own Docker containers, I just want to mention that actually you shouldn't really try and make your own Docker containers if you can reuse someone else's work. A big reason for why you should use Docker is that it encourages you to reuse other people's components. And if you want to find some components that you can reuse, maybe a complicated bit of software that you don't want to have to configure from scratch yourself, I would recommend looking in these three places. So there is the official Docker website, the Docker Hub, and there is a list of official packages on there which are packaged up by the Docker guys, and they have made and tagged them as official images, and there's things like PHP, Nginx, all the useful containers and stuff that you would want to run applications. Secondly, websites of software you're using. So a really good example of this is I had to set up Artifactory a little while ago, and it's a total pain. There's like a Java application, there's loads of config, and like I couldn't be bothered. But thankfully, on the website for Artifactory, they actually have a link to a Docker container, so you can just run that Docker file locally, have a play with it, see if it works for you, without having to do any real effort. And finally, key.io, that's where personally I publish my Docker containers. The Home Office publishes them there as well. It's very similar to the Docker Hub. Okay, so how do you actually make a Docker file, Docker container? So after a little while, you do tend to get to the limit of what you can do with other people's code, and I guess most of us are developers, right? Yeah. So we probably want to package up our own code and our own applications. Now, with Docker, you do it like this. So this is a Docker file, think makefile, capital D for Docker, all one word. And this lives in the root of your project. The top line is from. This implies a whole bunch of changes which have been made, in this case, in the official PHP repository, in the version which is labeled 5, configured with Apache. I know I should be using 7. I've just not got around to it yet. And this makes it really, really easy to pull in a whole bunch of work which someone else has done. In this case, I'm pulling in a load of work to get PHP and Apache up and running because I don't want to have to set that up myself because I'm really lazy. And as programmers, I think most of us should really try and be lazy and reduce the amount of work we have to do. The next commands are going to copy some files into the Docker container that I'm building. So the first one's going to copy my PHP application, then I'm going to make a small change, a htaccess file, and then finally I'm going to install a whole bunch of stuff to get Composer running and to get my application in a state where it's running. So it's installing the zip extension there, and it's installing Git and running a Composer install. And you'll notice that this line is really, really chunky and long. There's actually a specific reason I've done this, and it's to do with the way that Docker filing systems actually work. So a Docker filing system is based on layers. So the first layer is always a layer which indicates which other layers should be brought in as the basis of this Docker container. If you don't want any layers, it's called the scratch container. In this case, I'm pulling in all the changes which have been made for the PHP 5 Apache container. And then what I'm going to do on top of this is I'm going to create a new layer. So what I do is I execute the command in my Docker file, and then I save the delta between the differences and the change, and then at the top of that I generate a hash. So then I'm going to issue another copy command, a smaller one, that's going to be a smaller delta, and then it's going to save that in the file, and I'm going to generate a new hash. Then on top of that I'm going to run my command, and that's going to make a whole bunch of changes, and then it's going to save the difference, and then because it's the last one in the file, I'm going to tag it with a useful name. You don't have to use the useful name, you can use the hashes at any level. So what this means is that if you have, for example, at the bottom layer, copied in a whole bunch of massive files, and then in the next copy command, or you remove something in the next layer, they're still in the container, so your container is going to be absolutely huge. Obviously this is bad for things like secrets, and it's why I chained up all those commands to make a single run statement. Okay, so let's just show you this building. Okay, so that's my project. You can see at the top the Docker file, then there's the KB8, which is something that we use for Kubernetes that I'll come on to in a minute, and then there's my index.php and some composer stuff. So you'll notice here I'm running a docker build command, then that's that label at the top that I showed you, and you can see that it's actually starting to do the build. Now what it's doing is it's going away and downloading that container which I mentioned at the top of my file automatically, and then it's going to use this as the basis for my personal Docker container. So you can see at each stage we're generating that hash that I mentioned, and then we've got the final stage where it's going to do a run, and it's going to do some relatively complicated things. Not that complicated if you've ever installed Apache, I guess. Okay, so this actually means that there's something that's going to change in your system. So what this is going to do is it's going to change the artifact that you ship through your build system. So because now you're building a canonical thing which can be run anywhere without conflicts, you no longer have to worry about software conflicting with the dependencies, and you can run this on any environment at all. Okay, so it's built the Docker container. Let's just run this and prove that it works. So I'm going to name it Flappy again. You can see the Apache's output the log, so it's probably started up, but let's just hit the endpoint to be sure. Way, magic. Okay, so let's just stop that. So what I'm going to show you now is how you take this container that you have built locally and share it with other people, because reuse is really the key. So we're doing a Docker push, and it's going up to the remote image, to the registry, which is key.io. You'll notice that the same thing with the deltas, generating a hash of the delta for each thing. It's already pushed some of these deltas. This is based off a known base image, which is the Debian stable image, and then on top of that the PHP 5 guys have compiled their own container, and this container has the customizations for an Apache, so it's just going to push that up to the remote host. So there's something that I just want to draw your attention to. You'll notice that at the end of the URL there is :latest. This is the equivalent to sort of master in Git talk, so it's the default what we call label which we're going to name this container. So if you ever see that URL without a colon at the end, it's implying that it's going to use the latest image. Okay. Now, because you can share this other places, and you can run it on other people's machines, and it's going to be literally the exact same thing, and because you've got Docker isolating the code, you can run this on any environment. So this is now the artifact that you deploy to test. It is now the artifact that you deploy to production. It is the artifact that when, oh shit, everything's broken and you need to check out why a specific version of your code isn't working, you download to your developer machine. It gives you great consistency, and you know what's running where, and you can easily replicate live bugs. Okay, so I think it's just getting through the code that I actually wrote now. Yeah, magic. Okay, cool. So it's actually pushed it up to that URL, and if you visit the URL, you'll be able to see that specific version of my Docker container. Okay. Yeah, so as I've mentioned, your artifact is now the container that you move through your build pipeline. If you're like me and do some open source stuff, can I just see a show of hands? Who here does open source stuff occasionally? Has open source something in a week, maybe? Okay, cool. And you're too cheap to set up Jenkins or too lazy. You can use the Docker Hub, which has a CI server, and will do builds and stuff for you when you commit to master, which is really cool. Same with key.io. For both of these, you can filter based on the name of the tag. So your branches, which are like build branches, or like feature XYZ, don't necessarily got built. I tend to filter them, so I only build tags which have been marked up correctly with semver versions. Okay. So that's how you build Docker containers. Nice and simple. So the other thing that I've not really mentioned is how you package up your application to work well with Docker. So Heroku have this amazing guide on 12factor.net, and Heroku have been doing containers for quite a long time. So they pretty much got it down of how you do them really well. But just to summarize that, there's two main changes that you need to be aware of. The first of those is always log to standard out. It's really tricky to get log files out of standard out. Out of the internals of the container, because you need to do things with volumes and getting files in there, and it makes it quite hard to get the application log in a place where you can easily tail it. And you're also going to find that quite a lot of the tools that you use with Docker won't allow you to just randomly put a volume inside there. You'll have to do something a bit more structured. So it's always important to log to standard out, because that's where Docker expects it, and you can easily tail that and follow that in in your syslog or wherever you want. And the next point is you always configure environment-specific variables with environment variables. Now, the reason that this is important is Docker offers you a standardized way to pass environment variables into your Docker containers. So if you're trying to do things like inject like a JSON file or something which maybe has your settings in every single environment, or maybe building different versions, you soon found that like this stops working and everything starts becoming really, really complicated. If you stick to using environment variables for environment specific things, then actually it turns out you don't really have that many environment specific differences, and you're rapidly able to deploy this anywhere with a lot of flexibility. Okay, so this kind of brings us to the end of the Docker section. It wasn't too long, hopefully. And Docker is really awesome. It gives you a fantastic way of sharing applications in a working state with all the libraries and everything that you need to run them, and all the configuration. It gives you a standard interface to configure things. But it does kind of have a bit of a problem. What happens when you need to run Docker on more than one host? So this is where Kubernetes comes in. So there are a whole bunch of problems with running Docker on more than one host. For example, how do you maintain that Docker containers are still running all the time? How do you automatically restart them when they crash on a very basic level? How do you do deployments? How do you make sure that you release the latest version of your code onto every host? You have to SSH into every single box and run something. How do you make sure that you're monitoring this system? Is this something that you're going to sit down and write all yourself? Or are you going to be lazy and just use Kubernetes, which is what I like to do. Okay, so Kubernetes is fantastic. I really like it as a tool. It solves the deployment problem. Essentially what you do is you write some YAML files, you run them through the Kubernetes tool, and it will start up the whole environment all the way to provisioning you load balancers that you can access. And this is from a platform which you don't need to go and put SSH keys everywhere or anything like that. It solves the high availability problem by allowing you to specify a number of times that a container is run, and obviously offering a way to route to where in your cluster those containers are actually running. And it will do container state maintenance, so you can say that I really care about this application running. If it crashes, restart it. And you can also do things like, say if it crashes, I don't actually care if it stops. Okay, so before I come on to kind of some examples, I just wanted to talk about 4 key ideas in Kubernetes. So the first of these is pods. So pods are pods. Then there's replication controllers. Next, I'm going to talk about secrets, and in this, I'll touch on how you mount persistent storage inside your Kubernetes cluster onto your containers for things like database containers. And finally, I will round up and talk about services, which is how you can get an external IP for your things which are running inside your Kubernetes cluster. Okay, so pods are one or more Docker container running as a unit of scale inside your application. Now, what I mean by this is if you have two pods which two containers which run together to complement each other and require the same, for example, code inside them, maybe the same SSL secrets, maybe in this case, the same PHP code. You could have Nginx and PHP running as a single pod, which would be two containers which run on the same host as each other. They have access to each other's filing systems. You can mount them in volumes. And if one of them crashes, they both crash. And they both get restarted. If you increase the number of times that you want this duplicated, it will duplicate both the containers. So it's your unit of scale. Mostly, though, you're going to be running a single container inside a pod. So in my case, it's going to be a PHP running in Apache, or it could be MySQL, or it could be whatever other application. Okay. So replication controllers are the next part of this. So replication controllers say, I have got a pod and I want it to run X number of times within my Kubernetes cluster. This is done by like a single variable in some YAML files, which is really, really easy. And basically, this is what makes sure that your application, even if one of your hosts goes down, stays running. Even if your container crashes, it will Kubernetes will look at the replication controller and say, okay, so I should restart this host, and I should make sure that there's at least two of these running. Finally, services. Services are how to get to running containers. What services do is they act as a proxy. Essentially what they do is they get a DNS record and an IP address, and it has some open ports on them, and they will route through to open ports on containers which are in the running state. And these are, so not only do you get like a nice DNS entry with these which matches the name of the service, they're limited to a specific namespace, so you could have a test namespace, a dev namespace, and have different services running in each of them under the same name, so you can do things like have mail catcher maybe on test, and actually have a real SMTP server on prod. Okay, so let's bring this back to kind of an example which I've been showing you. This PHP pod is the Docker container which we built from before. And you'll notice that it's living inside a replication controller. So this replication controller has a replica count set to 2, so it's going to make sure that there's 2 of these PHP pods running. Sitting in front of that is a Flappy service. It's basically a DNS record which is going to allow my SSL terminating pods, which is just Nginx, to connect to my PHP pods. Those two SSL terminating pods are sitting in their own replication controller, and then sitting in front of those is a service which also provisions its own outbound load balancer, so it has an IP address which can be connectable from the outside world. Okay, so before when I showed you the Docker container, there was a whole bunch of YAML files in there. So this is the YAML file for the replication controller for the Flappy Endpoint pod. I know this is kind of long. The only thing that I want to say about this is pods live inside replication controllers if they're associated with a replication controller. So let's just look at the pod bit for a minute, and that was the bit in red. So you'll notice a whole bunch of things which are really similar to when I ran the application. So when I ran the application with Docker, we had an image, same URL, and we had that port mapping thing, didn't we? We mapped port 80 to port 80, and then we had the name. We called it Flappy here. I've called it Flappy Silex to differentiate it from the Nginx ones. But there's also a couple of new things. So there is a liveness probe. Now what this liveness probe it will keep querying. I think it's every 15 seconds maybe, the pod, and checking that it's actually returning a 200 from this response. And if my application breaks, it will stop the container, it will restart it again. So if my application ever gets deadlocked for some reason, it will restart that container. You can do this liveness check in other ways. There's one for doing execs inside the container if you wanted to check if a database was working or something like that. And there's also an image pull policy. The image pull policy is slightly less important. So basically what it says is, when I deploy this to a new Kubernetes cluster, tell the cluster to go away and look at the repository that the image is from, and just do a Docker pull, which will bring in the latest version of the image, even if it's already present on the Kubernetes cluster. Okay, so let's have a look at the rest of that replication controller now. So we have a few different things here. There's quite a lot going on in this file, but I'll just highlight the most important part. So the most important part is right below the word spec. It's called replicas 2, and what this says is it's going to run 2 instances of the pod contained within it. There are a few other things that are probably worth looking at. You can see this has also got a name, so it's Flappy Silex v1, and I'll be using that later on when I show you how to do an update. And there's also some labels down here. So these labels are associated with the pods, and they are how we make the services know where to look for the container. Right, so that's replication controllers and pods kind of done. So I'm going to talk to you a little bit about how you get data into containers and how you manage those tricky bits of data which maybe you don't want everyone to know about. Secrets, basically. In this case, I've got a SSH key, and you can see some base64 encoded data in those 2 variables, and there's like a name which looks kind of like a file name. So this is just a YAML file. You run it through Kubernetes, and Kubernetes will create this in your cluster. Obviously, you wouldn't commit your secrets to the same repository as you have the rest of your stuff. So it gives you a way to to get that information into your cluster separate to the actual structure of the application. Okay, so this is the replication controller for the SSL terminating pods, and it's quite long. So let's just look at the bits that are important. So it's basically exactly the same as for the pod, apart from these things. So we can see here that there's some volumes. So what volumes do is it says, make sure that this bit of storage, that this bit of data that is associated with this particular name, in this case I'm loading a secret, exists and can be associated with wherever I'm going to run in the cluster, which server I'm going to run these particular containers within them. Now, this bit is part of the replication controller. The top bit is all part of the pod. And what we're saying for the top part is, firstly, we're defining some environment variables of where to look for some SSL certs. And there we have the volume mounts. Now, what the volume mounts do is say, with the volume, mount this particular name inside the container. So this is really useful. So firstly, it's really useful for secrets. But this is also how you mount, say, for example, persistent storage inside your containers. You would define something which looks slightly different to the secret. It's you issue what is known as a persistent volume claim, and for a specific amount of space. It looks relatively the same. It's in the volume section, and if that's available, it will get mounted inside your containers. Say your containers crash and get restarted on a different host, that volume will follow your containers. So you'll get persistent storage wherever you run it. Okay, so this kind of brings us to the load balancer. Now, the load balancer is actually just a specialized kind of service. So this particular service is the one for the SSL terminator. There's not very much to it. There is a name, that's going to be our DNS record. There is an IP address that resolves to as well. We've got some ports, so we're saying here, open port 80 on this service, and then on the containers, try to connect to a port which has been named HTTP. And then we have HTTPS, because this is connecting to the SSL container. There's some selectors just below this. Now this says precisely which of the pods that it should be connecting to. So in this case it's service and it's type Nginx. And it will connect to any of the pods in a kind of round robin fashion, and it will allow you to connect through. This case is actually a special kind of service because type load balancer, and what this does is it instructs your service provider, so AWS, Google Compute Engine, to provision you an external load balancer. So you get an IP address for the service which you've just deployed, and that all happens magically behind the scenes. Okay, so because I've been talking so long, I suspect that you've probably forgotten what this example actually is. So we have the Flappy endpoint here. It's got two URLs, one which just returns 200, and one which returns a different response every single time. Magic. Okay. So after a while, after you've been developing your application, there does come a point when you actually need to release this stuff, and hopefully it goes pretty well. Now, with Kubernetes, it's actually really, really easy to launch an application. So it's one command. So kube control, I'm just going to prove to you that this isn't actually already running because it just goes so quickly. And there are no containers in here labeled. This is my personal Kubernetes cluster, by the way. I liked it so much I started using it. There's no replication controllers which are called Flappy. So I'm now going to issue a create. And that was just on the YAML files, which are in the code repository, which I showed you earlier, and that we've just been through. And what this does is it tells Kubernetes to start some pods, and you can see the Flappy Nginx ones there, and they've just started running. And then at the top we have two services as well, so Flappy Nginx and Flappy Silex. Now the Flappy Silex is just an internal service, so it's got its IP address, and you'll notice there's a gap underneath the Flappy Nginx pod just there. And this is where, in a few seconds, Google Compute is going to provision me with an external IP address that we can use to connect to this service. Cool, so if I just open that in a browser, I should be able to view it. Ta-da! Works. And that's all there is to deploying an application with Kubernetes. That's like ridiculously easy, isn't it? No faffing around, passing SSH keys places, or provisioning servers or anything. Cool. So once you have an application, I love this GIF. So once you have an application up and running, sometimes like you need additional features adding in, or sometimes a feature which was slightly unexpected, maybe the feature where it crashes all the time, has snuck into the code base and needs to be resolved, taken out. So Kubernetes also provides you a really simple way to update the code, which is running inside your Kubernetes cluster, running inside your pods, and it does this by using a rolling update. So in this example, I'm just going to add a new endpoint. So you can see this is my Silex application. There's a v2 endpoint which 404s, and I'm just going to add in a new endpoint which is going to return something when I go to v2. And because I'm a good citizen, as well as doing this, I'm going to update the comment. Okay, so you guys have all seen Silex before, right? It's pretty easy stuff. Okay. What I'm going to do with this is I'm actually going to deploy this in a slightly different way that I've showed you previously. So rather than me doing the Docker build on my machine, I'm just going to push this to GitHub, and I'm going to get the key.io to do the build for me. Because, I mean, that's realistically something that you guys are probably going to do for your first project, right? That's what I do. Okay, so I'm now going to visit key.io. I'm a fan of questionable content as well. That's good. So here is the repository. You can actually visit this now and have a look at what builds have been going on in this branch. And you might notice a surreptitious edit there. So when I was filming this, there was something going on with key, and builds were taking 10 minutes. So I cut out the build process. But it's just the same as when you do a Docker build. Now they're taking about 3 minutes, so it's fine. So what I'm going to do now is I'm going to look up a unique name for the particular container inside the pod that I'm going to run. So I'm going to look up, and you do this by, if you have multiple containers running inside a pod, you need to give a specific name for the pod. But in this case, because I've only got one container in my pod, I'm just going to use the Flappy Silex v1 container, and I'm going to deploy the image, which we just built here, onto the cluster. So Flappy Silex v1. and off it's going. Okay, so this particular command does something which is fairly specific and requires me to have two hands. So what we do is we start off with 2 old containers because the replication controller was set to 2. And what it does is, firstly, it will spin up 1 more new container. It will wait 60 seconds for that to be ready, and then after 60 seconds it will kill 1 of the old containers. And now you've still got 2, the minimum of 2 containers running at any one point. And then after this, it will start up a third, 2 new, 1 old Docker containers. And then finally, after 60 seconds, it will kill the old Docker container. So you're running 2 new instances of the Docker container without ever reducing the amount of times that you're running your application. Okay, so now this is obviously not ideal for everyone. You can actually do green-black deployments with this by replacing the service and inserting a new replication controller with a new reference to a different URL. So you could have 2 different versions of the container running at the same time and then switch it over by replacing the service. Okay, so we're now on to the second stage. So there is 2 new containers and there is 1 old container. And hopefully, I will flick over to the browser in a minute and show you both of the applications loading in a round-robin type way. Unless I messed up my timing. Yeah, there we go. No, messed up my timing. Oh, there we go. Okay, so I'm now getting the 404 page, and I'm also getting the actual correction page. Yeah, so working, not working, working, not working. That's because we've got 2 different containers of the different versions. I would say that this is probably not ideal for every situation, because obviously you probably don't want 2 different versions of your code running at once. But actually you can resolve this by deploying in just a slightly different way. But this comes out of the box, and I can't be bothered to change it for my personal hosting needs because I don't have anything more specific to do. Okay, so it's now finally finished deploying both containers on the same version, and regardless of how many times we hit that page, it will be fine. So if you hit that URL now, I think you would be able to see that endpoint. Okay, so I think for me, Kubernetes solves what is a bit of a guilty problem of DevOps in that Chef, Puppet, Ansible, and maybe Bash scripts aren't really reusable. Say you update your host, it turns out that actually you need to rewrite all your Ansible because maybe a package name has changed. Like you try and reuse someone else's work, but maybe it doesn't quite work on your version of Ubuntu, and it only works on X version of Yum. Generally, it's a big mess, and you can't reliably reuse anyone else's work because you know that it's probably going to break. This means that a lot of time in DevOps you're going to be spending time reworking code, which you should already have finished at least once. And Kubernetes gives you a definite way that you know that this code is going to work because you're basing yourself off a known image with known versions of software and known configuration. So you don't have to use any of these horrible things, which I hate. So no configuration management. You get rolling updates out of the box. You get deploys out of the box. You get health checks, so if your application messes up, it restarts, which I know sounds like a small thing, but quite frequently dev people don't really pay much attention to this or notice that it actually needs doing. It gives you services, and it's really easy to create highly available systems within a particular deployment zone because you can just say run 2 instances of this and it'll make sure it's always connectable using this service. Something that I've not really touched on that is possible with Docker and Kubernetes is you can set a resource limit for your containers and pods. You can say that actually I only want this particular container to use maybe 100 megs or 5 gigs if it's a Java app. It's from personal experience. And you will limit your application to using that amount of memory. So you won't ever get the situation where like you had that one dodgy script which maybe used too much memory and crashed your host. And you can do the same thing with CPU time. Yeah. Okay, so as I mentioned at the start, like the technology is really only half the battle. So I'm now going to talk to you about some of the problems that we had at the Home Office and kind of how we shifted from reusing and reworking our DevOps for every single platform we deployed to being a team that provisioned platforms for developers to use. So the reason that we came to look for these tools that I'm talking to you about today is that we had a problem, and 90% of the time when we came to a new project, it would require some level of isolation. So that meant provisioning an entirely new zone app project in your hosting environment. It meant running and rerunning Puppet scripts, rewriting them, or Ansible, or whichever the DevOps engineer preferred. And because each of these environments, because they were deployed at slightly different times, maybe had slightly different versions of the operating system, we found that we had to rework lots of our Puppet, and it was just a big mess. It was really untidy, and it was throwing away lots of rework all the time. So we went on a journey essentially to maximize reuse inside DevOps and change the culture so that we didn't fall into the same trap of using these tools but rewriting everything every single time. So I'm going to first talk about what we kind of reuse at the Home Office and which particular items we attempt to open source, but also make sure that we don't duplicate. And I'm going to talk about some of the changes we made as a DevOps team in order to switch from thinking like we are delivering the ability to maybe configure a HTTP server somewhere to being a team which delivers a Kubernetes platform and a PaaS environment which developers can rapidly deploy their own code to and iterate frequently. And obviously, because the Home Office has lots of your data, I want to convince you that we take a lot of care with security, and I'm going to give you a couple of tips for making sure that when you deploy Kubernetes and Docker, that you actually do it securely. Okay. So the things at the Home Office that we reuse code, so we've been making libraries and things quite frequently. It's maybe not been that reusable in the past because we've just dumped stuff on GitHub. We've committed that sin that I think Jordy mentioned, where we just open source something by changing the setting on the repository. But we've changed that fairly recently. We also reuse Docker containers, so we make reusable elements of infrastructure which people can take and reuse for common tasks. So things like a web application firewall, like a reverse proxy which terminates SSL, all those things pre-made. Don't need to write them, just get a Docker container. And we also reuse environments. But we reuse environments in a very specific way. So we offer like maybe a secure environment for like secret squirrel stuff. And we also offer a public cloud environment for less secure stuff, but still important. And maybe for some very specific applications, we have like segregated bare metal servers. Okay, so let's talk about reuse. So in order to improve the amount of reuse we were getting inside the Home Office, we thought, right, problems are hard to solve, so let's look at other people who've solved them already. So what we did is we had a look at the world's most successful reuse project ever envisioned, and that is the open source movement. So we thought that we would nick some ideas from them. And the first idea that we had says it's open source, so we'll just start working openly and that'll magically fix everything. So we changed how permissions work on repositories inside the Home Office. So you become a developer at the Home Office and you instantly get access to all of the repositories, barring a few things for security. And this didn't really work. So it was a good start. Some people could kind of see that there might be something that they'd reuse, and the process would go something like, oh, I contact the person on the team, and they go, actually, it's not really reusable. But you could kind of see stuff was out there. So we thought, okay, so how can we make this code be in more of a place so that it's actually reusable by other people? And we thought, well, let's look at the open source community again. How do they handle this? So we looked at the attributes of really good open source projects, and we noticed they had versioning, they had lots of other cool stuff in there, stuff that we really wanted to introduce inside the Home Office. And we thought, okay, so how do we get that culture inside the Home Office? And the answer was for us to open source it. So we started identifying components which weren't directly related to our business roles, and we would just release them, open source them. We'd make sure they had documentation and stuff, and they would be out there and people could actually use them. And what we found is this actually encouraged people to be good people. And what I mean by this is people have a certain amount of pride in their code, especially when it's being used by lots of other people. Open source was an opportunity for this to happen. So we found that people were going and putting versions on stuff. They were writing beautiful documentation. We use Semver at the Home Office for versioning. Very important. You should do that. They included licenses and, importantly, codes of conduct. And we got this whole culture of people open sourcing things and making really nice open source projects. And this fed back into our own internal things. So things that we couldn't open source, because this was now the norm to have all this cool documentation about how to use things, including DevOps elements such as proxies, web application firewalls. We brought that culture into our own organization, which meant that the stuff we couldn't open source was actually reusable internally as well. A really nice side effect. Okay, so that's how we got the people reusing things, and we started introducing a culture of reuse inside the Home Office. Now, because this is specifically about DevOps, I'm going to tell you some of the things that we did. So what we started doing, as well as this, is after we had the success of getting open source, we were like, okay, so who else's ideas can we steal? So we looked at people who'd really successfully made platforms for delivering code well. We thought, okay, so if I was working at home, what's my preferred way of deploying code? And lots of people said things, well, I just went to a cloud provider, you know, and they have lots of things pre-made for me, so like I don't need to work out how I'm going to do like fast file downloads because there's S3. I don't need to worry about databases because there's I can use RDS, or I can use Google's Cloud SQL service or Aurora. I don't need to worry about ticketing systems because that's kind of built into everything. I didn't need to worry about CI because I used Travis. So we thought, okay, so what we need to do is we need to start providing these services to our developers internally as services. So internally inside the Home Office, we now have the ability to solve commonly used common problems that people have with their applications, like how do I serve files to our users in a secure way, just off the bat. We also provision sort of more traditional things like Git, so people can have their own internal repositories if they want. And the most important thing, the most important service out of all the services we provide was Kubernetes. Now, Kubernetes was key to our success in reusing environments. So Kubernetes in the Home Office runs on a few different things. Generally speaking, we use CoreOS running on different base systems, but that's not always true. What is true, however, that the user's interface is always the Kubernetes API. So they can use the Kubernetes command line tools, and regardless of like which environment they're deploying to, be it super secret squirrel stuff or like public gov.uk stuff, they can actually just use the same tools and the same bits of configuration that they've always used and not worry about the details of the delts in the background. So it means that actually the code and tools to do deployments are exactly the same. And what this means for you, if you don't have these sort of multiple environment challenges, is that if you decide that maybe you're using AWS at the moment, but you decide that fast hosts is like the way to go from now on, you can move all your code and applications from AWS to fast hosts by running Kubernetes on there. Because so long as you provide the same interface, your code is always going to run exactly the same, so long as you provide a Kubernetes service. And the great thing about this is Kubernetes comes pre-made in some commodity distributions such as Atom and CoreOS, so you don't even need to put any work in to install it. There's pre-made distributions which are specially for doing exactly this. And this also means that it's really easy to get running as a dev because it runs in Vagrant. So I'll give you a link on at the end of the thing about getting Kubernetes running in Vagrant. It's really, really easy. But the key thing I want to get across is as a DevOps team, we develop a Kubernetes platform with some ancillary services, and the standard interface and the standard product we deliver to our customers, the devs, is Kubernetes as a PaaS. Okay, so I'm kind of coming to the end of my talk now. So there's a few tips that I want to give you about security. So Docker is a really amazing tool. Docker is an amazing tool for allowing you to reuse DevOps elements over and over again. And it isolates your programs really well. but it doesn't do anything to protect your applications from the data that's coming into them. So if you've got like a buffer overflow exploit or something in there, you can still get hacked, you can still get XSSs on your website, you can still have SQL injection attacks. So run a web application firewall in front of your applications. Make sure there's some protection for the application itself. Like, I like to think that I write perfect code, but the truth is that I don't. Sometimes I make mistakes, and having something which is going to protect you from a web application firewall, from attacks from the internet, is just common sense. It takes no work. You can reuse, if you don't have one that you prefer to use yourself, there's actually one which the Home Office has open sourced and configured for you. It's based on Naxos and Nginx. It's called the Nginx proxy. I'll give you a link to the Home Office's GitHub, and you can actually run that. It's what I use. Super painless. Okay, so as well as protecting your applications from attacks through data coming into your application, you can also control your upstream containers. This is something which is really important. So effectively, when you do a Docker build, you're freezing your application in time. So if in 6 months you're still using the same Docker container, or maybe your upstream container hasn't released an update, you will be running vulnerable code. Within 6 months, all operating systems have exploits which have been published with them to varying degrees. So it's important that you keep rebuilding your containers on a fairly regular basis, and it's important that you choose an upstream container which you know is going to be up to date. For the security restrictions that they have at the Home Office, we actually have a specific base image that we use, but it's just as true that if you use one of the public official images, so long as you rebuild your container fairly frequently, you're going to be pretty safe from SQL attacks. But you do need to make sure that your upstream container is providing you with updates. And finally, after advocating that we can reuse loads and loads of stuff across multiple environments, one of the key reasons for doing this is so that we can actually split these environments up. So one situation that you don't want to find yourself in is if you have for example, lots of customer bank details, you don't want them running in the same database server as the rest of your application. Say the rest of your application gets hacked, you still want your customer data to be safe. So it's very important to not put all of your stuff in the same environment. It's important to separate this out so that if you do get attacked, you haven't got too much danger, too much of a valuable target which would be targeted by everyone. So basically, you need to separate your environments, you need to separate your code into, to make sure that you don't gather lots of high-value targets in a single place, which is going to be really embarrassing if you get attacked. Okay, so I think this Kubernetes is really cool. I think there's been really interesting stuff going on at the Home Office at the moment. It is still pretty early days, so I mean, this really only happened before Christmas. It does make management really easy. Like I said, I like it so much that I started using it for my own deployments, all my blogs, my Twitter bots and stuff like that, really important things. All run on Kubernetes because it means that I don't have to think about DevOps. I just write a couple of YAML files and then it's sorted. It's hosting agnostic, so you can migrate to cheaper hosts when you want. And you can also run it on bare metal, which is obviously a choice some people make. You can reuse everything, and more importantly, you can play with it today. So that top link is a Vagrant file where you can actually run Kubernetes. The next link down is some example code. It's the example code that I've been through today, so you'll be able to run that. I think there's a link to where it's actually running, which is flappy.purplebooth.co.uk as well on there. There is the Home Office GitHub account, which has got loads of Docker containers that you probably want to reuse. It could save you some time. And the last link is the most important link. It's Unjoined In, and I really, really like giving this talk, but it's really hard to know what I should do with it. So if you've got some feedback, please give it that URL. I'll put the slides up on Joined In when this talk's over as well. So yeah, that's it.
Thank you very much, Billy. Thank you. We do have some time for questions. Fortunately, it's prior to lunch, so we probably can stretch the time for questions if need be. Microphone, please.
In the example you were showing where you were redeploying,
yep.
And you had a URL that returned an error because you were halfway through, leads me to wonder about session management. How do you deal with session management if you're running multiple PHP containers?
So session management is a tricky question. I don't actually know I don't actually know how you handle that. I always avoid having session management problems by either making sure that my sessions come from a key value store or writing stateless applications. I know that's not always possible, but it's just not a problem I've had to solve, so I'll have to look into that one.
Okay, we've got one next door.
Oh, next door, cool. Oh, 1 minute.
Hello. So I can see how Kubernetes high availability stuff can help for stateless things like PHP. What solutions does it have for example, the MySQL container with data in it?
Sure. So data and persistence with storage is a really tricky problem for Docker. It just doesn't work very well with things like databases. However, you saw how I mounted the secret inside the Docker, inside the pod. You can do the same thing, but with persistent storage. So Kubernetes has an idea called volume claims, and what volume claims are is the administrator of the cluster will define some volumes of a specific size, which can be mounted inside your pods. These are requested by a volume claim which has a specific size, and these volumes which are defined, which you can claim, are associated with a specific type of storage. So this might be like RDS, for example, or it might be something built into your hosting provider. So it could be Amazon's persistent disk storage as well.
Okay, thank you.
Hey, thank you. So first of all, on the sessions thing, I'm no expert, but I imagine that you'd configure your load balancer to do sticky sessions, so it would always send an individual user to the same instance. But yeah, I'm no expert. My question, I probably missed this, but I saw how you were redeploying your containers up into Kubernetes, but like, how does your code get up there? Is one of your containers configured to pull it over from GitHub, or what? So
as part of the build step, I issue a copy command. This copy command copies my code into the Docker container. So essentially as part of the Docker build, that's when I get the code, that's when I put it inside the Docker container. So the Docker container lives at the root of my application's repository. So the idea is that you would just run Docker build on that particular file. Docker can take the files which are in the same directory and things, it can copy them, it can selectively add them. It also has some capacity to do things from URL, but the point is that you can copy the files into your application.
And that happens on your local machine before it's all set up?
Yeah, so I mean, in the case if you're using something like Key, it checks out your GitHub account and then does the Docker build. For like more complicated CI environments, where you don't want to have any of your code actually on the machine. So if you're building a Go application, what you can do is you can have two containers. You can have a build container where you do the actual build and then you output to a volume like the compiled version of the file, and then you have a run container, which is usually like a subset of, which is usually the base image for the build container, and you copy the compiled thing into the container.
Cool, thank you.
Oh, was the question for that?
Hi, I just want to ask, how does Kubernetes handle service discovery if you've got more than one containers?
Yeah, so the services themselves have DNS names associated with them. These DNS names are specific to what's known as a namespace in Kubernetes.
Right.
So you could deploy different things, different actual pods for different services depending on which environment. If you're talking about more complicated service discovery, like how do I know, for example, an SMTP server runs over like start TSL rather than SSL, for example. That is sort of an unsolved problem. You could use SRV records, but it's in no way like something which is supported out of the box.
So each pod can actually know what's inside the pod as once you
yeah,
deploy.
hang on, I'll flip back to this because it kind of makes more sense if I have a picture. Too far, not far enough. There we go. Okay, so these services. So imagine this living in something called a namespace. The Flappy service is essentially a DNS record which is called, I think, Flappy Silex. And you can just resolve that IP address. It will point to a special IP address in Kubernetes, which when you connect to it, it will route to any of these two pods, which are first in the running state, but also it matches up to the pods that it knows. If I flip back to the load balancer example, so you can see here it's got the selector, so that's how it knows which pods to connect to. So it's a DNS name, that's how you do service discovery basically. I know that's not quite full service discovery with like full configuration, but I think there's some other applications and things out there which will do that for you, so depending on what you're kind of looking to do. I can have a more in-depth conversation with you about that afterwards if you want.
Okay, thank you.
I'm just wondering how the different developers are working at the same project to cooperate in using Docker containers in this way.
Oh, okay. So if two developers are working on the same project, what they do is they just do it in the same normal way. They have a Git repository, feature requests merge into master. Typically, you have some sort of CI server which does the builds of your containers. So when you decide that a particular container, when you decide that a particular bit of code is ready to be deployed, you can choose to deploy the code from a specific place. There's nothing particularly special about how you would work.
But how do you get the modification that other developers have done in the same time? It's a kind of a merging process of how.
Oh, I mean, no. So it's not. If you do, say, a Docker push to an image which already exists, a container, it would just overwrite it. So you just work in the same way that you would with just a PHP application now. So when you do a deploy, you still hopefully build some sort of asset in your CI server and deploy that, be that raw PHP code or an RPM. So Docker files work exactly the same way. So the artifact that you build, rather than being like a set of files or a particular RPM, are what you deploy to the server. So you could actually do a Docker build locally if you've made some changes for a specific version of your application in order to maybe get something working. You want to test it, you could do a Docker build and run it. That would also work.
Thank you.
Cool.
Okay, any more questions?
Yeah, I'm just extending this gentleman's question about copying the code. So is it a good practice to copy the whole code before every build, or is it better to symlink it instead because it's still in the same directory?
So when you do a Docker build, there is no previous state, so you're building a new thing. So it's not like you've got multiple versions of the same code inside the Docker container. You should be just copying in the latest version. You only need a single version inside the Docker container because you can use, you see the label at the top there? You can put a version on the end of the label and say this is version 1, this is version 2, this is version 3. You do it with like a colon, so without the colon on there, that's referring to the version called latest, but you could equally build versions which are specific Semver versions.
So that means we build it locally and then push it, and it automatically picks it up then, the latest version.
Yeah. So if you were to release a new version of the container to Kubernetes, you would have to tell Kubernetes to do something like a rolling update or deploy new replication controllers and change your service.
Great, thanks.
Have you had any experience with DB replication cross containers, or is that the wrong tool for the job?
So I hate using databases with Docker. I find it doesn't work very well, mostly. So what I try to use is services which are pre-made, so for example, Amazon's RDS service. I have had a little bit of experience. It kind of works, but it's sometimes a bit flaky. Generally, persistent storage with Docker containers doesn't work very well. So try and use a service which someone else has made. That's my advice.
Okay, I think that's it. Another round of applause, please.